Thanks so much for that introduction, Lee. I'm really excited to be here, so thank you for having me. As mentioned, my name is Leanne Shapton. I work at Shopify. I'm a software developer there, located in Toronto, Canada. Shopify is an e-commerce platform that allows people to sell products online. Like many platforms, Shopify encourages third-party developers to build apps and services on top of our software. And the work I do is primarily around extending Shopify's platform to enable developers to do this. So I joined Shopify actually back in January of this year. When I started, I joined the Storefront API team. At the time, the team was busy preparing to launch Shopify's first public GraphQL API, which they successfully did this spring at our conference called Unite. In prepping for this launch, my responsibility was to create example React apps that would show developers how to consume our new GraphQL API. Before joining Shopify, I had heard of GraphQL, but I had not yet worked with it. So I began the process that us as software developers are all too familiar with, is learning a new language. If you read my description to my talk, Teaching GraphQL Lessons from a Beginner, you either related to it because you yourself are new to GraphQL, or you're a team lead and your company has decided to adopt GraphQL as part of their stack, and you're responsible for teaching the rest of your team. So what we'll talk about today is I'm going to speak about my experience learning GraphQL and also speak to other developers at Shopify, their experience learning GraphQL. But I wanted to talk about how we learn new skills just briefly. I'm going to introduce a model for learning new skills. And we'll see in this model that there's a big difference between beginners and experts and how they see a problem and how they tackle a problem. And using that information, I'm going to deliver tools that I think are useful for teaching GraphQL to beginners. So starting with a model for learning new skills, we have all been there as beginners. We've all started to learn something new, and sometimes things come really easily, and sometimes they just don't stick. So in educational research, there's this thing called the Dreyfus model of skill acquisition. It is a 5-stage model that explains each learner will go through these different stages as they acquire new skills. I first heard about this model at a workshop in Toronto by Greg Wilson called How to Teach Programming and Other Things. Greg took this 5-stage model and actually simplified it into a 3-stage model. I'm going to actually use his 3-stage model for the purpose of my talk today. So when you start learning something new, you would identify as a beginner. At this stage, you don't know what you don't know. You will make false associations based on surface similarities. For example, you may hear GraphQL and think it's a programming language that makes charts, because those are the types of graphs that you know. It is not, and it will be clear in the tools that I show later. But this is not that crazy of an idea, because oops. It's not that crazy of an idea because if you are new to a new domain, you don't have enough context, and therefore you rely on other domain knowledge that you do know to fill in those gaps, and this is sometimes where you make false associations. Another common feeling amongst beginners is that feeling of being stuck. We don't have the experience, if you're new to a new domain, to look at a problem and know what's important about that problem and the steps to solve that problem. Therefore, you require step-by-step instructions to do anything in that domain. This is very frustrating as beginners. As you develop new context and gain more knowledge, you graduate from being a beginner to a competent practitioner. And this is a really good place to be because you've developed a usable mental model that is good enough to solve normal, everyday problems. Another thing when you're a competent practitioner is that your mental model may not be completely accurate, but that's okay. For example, you can drive a car every single day and know how to change the oil or change the tire, but you would still bring your car to a mechanic to get the brakes fixed. You have a good enough mental model to use your car every day. Another thing that competent practitioners do, because they have enough experience, they can look at a problem, identify what's important about that problem, and know the steps to solve that. So they imply analytical decision-making. As you gain a lot of experience, you graduate from a competent practitioner up to an expert. At this level, your mental model is actually so complex that you may not know the individual components that make this up, and therefore you will look at a solution and intuitively know the answer. This is almost like second nature, so it's hard to know. You may not actually recognize the steps that you take to solve a problem because you have so much experience in the domain that you intuitively know the answer. They say it takes about 10,000 hours of practice to become an expert, so today we're not concerned with becoming experts, but we are concerned with developing a good enough mental model so we can solve normal everyday problems in GraphQL. So the big difference between beginners and competent practitioners is knowledge and context. Knowledge is really easy to consume. You can read a lot of text, you can read the docs, you can watch YouTube videos, but it's the context that makes the difference. Without the context, you don't have a mental model so that when you learn new information about GraphQL, you have no good place to store it, and this makes remembering or retrieving that information later very difficult. It makes learning actually not that effective. So where competent practitioners have a really good mental model, so they learn more effectively. When they hear new things about GraphQL, they're sitting in the audience listening to all these conference talks, they're able to take that knowledge and store it in a good place so that later when you're back at work, you can remember and retrieve that more efficiently. So I've used this term a bunch, mental models, and just before going further in my talk, I want to make sure I properly define it. Mental models are conceptual frameworks. They consist of both generalizations and assumptions, but they're good to use to understand the working of things. So the remainder of this talk, I'm going to focus on building a GraphQL mental model for beginners. I really like this quote. All models are wrong, but some are useful. So in preparing for this talk, I started with the mental model that I used to learn GraphQL in order to build those React example apps. I then took this mental model, showed it to a bunch of developers at Shopify, asked them what they found confusing, what made sense to them, what they already knew, and where some of the gaps were. What I discovered talking to a bunch of developers about APIs is that there's some key ideas that are top of mind. These being client-server basics, CRUD operations, HTTP methods, and Restful APIs. So when I build my mental model today, I'm going to do it in stages. I'm going to start with these key ideas. I'm going to lay the framework of kind of what we already know about APIs. I'm going to introduce some new concepts that are related to GraphQL, and then I'm going to add those concepts on top of our mental map. I'm also going to share some insights from my experience learning GraphQL as well as other developers at Shopify about kind of what is well understood within these key ideas and what may not be super well understood. And the things that aren't well understood may lead to confusion when learning GraphQL later. As I show you several iterations of this mental map, I've used some symbols. So the light bulb recognizes identifies key ideas, and the pink arrows will draw associations between these key ideas. The reason for this is to model how the mind works. The mind will group ideas in particular locations, and then we'll draw associations between that, so it's easier to remember and retrieve that information later. So let's start with what our developer already knows. When we talk about RESTful APIs, most developers understand this client-server model really well. We know that there's a client that's a user interface. It could be a mobile app or a web browser, which communicates to a server that's over there, that's separated from the client, and this communication often happens over a network. We also know that it's a uniform interface. We might not use this term, but we know that regardless of what client I am, I'm going to interact with the API in the same way. So if I'm a mobile app or a web browser, I will hit a resource endpoint to get data from that particular resource. The other concepts that define what a RESTful API are the constraints that make an API RESTful, are not as top of mind to developers. They may be known, but we may take them for granted, so that there's a layered system. So the client interacts with a server or communicates with a server, and that server may have another endpoint, but the client's not really concerned about that. It's statelessness, so that the client holds the state between the request and response lifecycle, and the client can cache responses from a server. When we talk about CRUD operations, most developers know that stands for create, read, update, and delete, and these operations are defined on a particular resource. What is not clear to developers is that the CRUD operations actually map to an HTTP method. We, for example, will use a GET request to either fetch data from our server, and that server will execute a read operation. Similarly, with a post, if we want to create a resource, we'll use an HTTP post request, and that will execute the create operation on our resource. This is sort of a mapping that we may take for granted, or it may not have ever been clear to us. So let's take these key ideas and lay them out in a framework. So I have my client. I also have a server that has my data. And between these two concepts is my Restful API, so my interface. The Restful APIs that we're most familiar with group a server's data by resource. And they have multiple endpoints to, that a client would access to be able to get that resource's data. On each resource, we define CRUD operations to modify or fetch data related to that resource. So if I'm a client that's interacting with a RESTful API that we're most familiar with and have compared to a lot in this conference, is I would use an HTTP GET request to a particular URI, which would execute the read function on that resource. That read operation would fetch the resource data from the server and then return it to me in an HTML, XML, or JSON response. So let's talk about some GraphQL concepts. When I surveyed developers at Shopify, I asked them to define or explain what they thought GraphQL was. A lot of front-end developers were aware of one of the big pros of GraphQL, that the client can dictate the format of data in the response, which solves that overfetching problem. What is not really clear to a lot of developers is what GraphQL actually is. So the definition of GraphQL being a query language for APIs, developers couldn't explain that well, or it had never been explained to them. Also that there's only one endpoint when it comes to GraphQL, and it returns a data graph. There's a type system that defines all queryable data. Describing what the graph in GraphQL is a very clarifying concept if you're new to GraphQL. Understanding that the server's data is organized in this graph data structure makes a lot of sense and is a key point to clarify early on, that what GraphQL will do is the node of this data graph will be represent your objects, and the edges between these in your data graph will represent the relationship between these objects. And that GraphQL requires a type system. So each object that you represent in your data graph that will be accessible by your GraphQL API needs to be defined in your schema as a type. So for example, we have the type shop. It has two fields, name and products. The products is an array of another object type that we would have to define in our schema, being product. Like any programming language, things come out of the box for you, and some of these things that come out of the box for GraphQL is it defines query type for you. So this is just another object type, but you don't have to define it yourself. It's an entry point into your data graph, and it represents the tree of all objects that are queryable by your API. Other things that come out of the box with GraphQL is it defines object types like scalar values, so integers, booleans, and they define it already for you, so you don't have to do that. The second key idea when it comes to GraphQL are resolvers. This was also another clarifying point for developers, is that a resolver is what's responsible for accessing your data. So where we're used to CRUD operations, either fetching or modifying the data from our server, in GraphQL, resolvers are responsible for this. And where CRUD operations are defined on a resource, resolvers are defined on an individual object. So each object type in our data graph will be backed by a resolver. So when we add those key ideas on top of our existing mental map, we can see that GraphQL API is just another interface. It can exist at the same time as a RESTful API. And there's only one endpoint. It organizes our server's data in a data graph, where the entry point is the query type. Each node is defined as an object type in our schema and is backed by a resolver. So if we kind of take that in, we'll notice that GraphQL API is actually a RESTful API itself. And that's because GraphQL, if you looked at our mental model, you'll notice that GraphQL follows all of the 5 mandatory constraints that make an API RESTful. It still uses the client-server architecture. It's a uniform interface, so regardless if I'm a mobile app or I'm a web browser, I'm going to hit just one endpoint. It's still a layered system that the server can have another endpoint, but my client doesn't care. the client will still hold the state between the request and response lifecycle, and the client can cache the response from the server, which we heard earlier in a talk today. But GraphQL is more than that. It adds additional things to this contract between client and server, and those were some of the key ideas that I talked about, being one endpoint, that it has to have a type system, and that it also organizes the data in this data graph. And this is what makes the difference between what we're used to with common RESTful APIs and GraphQL, and makes why fetching and modifying data through a GraphQL API is different from what we're used to. So what's really confusing to developers is that you use an HTTP post request to fetch data and not modify data on a server. And this is because with our common RESTful APIs, we define CRUD on our resources. And there's a mapping between the CRUD operation and the HTTP request. Because we don't define CRUD on our GraphQL API, there's no mapping. So the HTTP method request is actually not important. We're using the HTTP post request because it has a body. And the reason we need a body is the client dictates what objects that are queried on the API and the format that they are returned. So you see I have an HTTP post request. I'm including a nested group of objects that I want back from the server. And my API will start executing, starting at the query root. Based on the objects I sent it as my client, I'm going to start traversing the data graph for those objects. And every object I hit, I'm going to execute the resolver. The resolver is responsible for creating the JSON that's sent back to the client. And it does this by taking the name of the object as the key value and the resolved value as the value. So one of the things that we learned early on in GraphQL is that the server's JSON response mirrors the client's request. And this is why the client can dictate the format of the request. And it makes sense when you think about it because we lay out, we dictate how we're going to traverse the data graph on the API based on the nested objects we send to the API. So it will start executing, traversing that data graph, and build the JSON response at each object level. And the object name becomes the key value, as I said, and the resolved value becomes the value. So how does this work for modifying data? Another thing that comes out of the box with GraphQL is mutation type. Mutation type is defined for us, and this is a second entry point into our data graph. So like other object types, we can define fields on our mutation types, and these fields are going to be what are our mutations that we allow on our API. For example, I have a mutation called Mutate Resource 3. I pass it an argument of what I want to update, and then it's going to return the object type Mutate Resource 3 payload. I'll have to define that object type in my schema, and it may have fields that relate to other object types that already exist in our data graph. So my mutation ends up looking something like this. I'm still using HTTP post request because you remember my HTTP method doesn't matter because it's not mapping to a particular operation on my API. Instead, I'm using a post request because I care about that body that I'm sending. I still like sending a query. I still need to send what format of objects I want, what objects I want back from the server and in which format. But I define a few other things. I'm now going to start at the mutation root, and I'm also going to tell which field I want to execute on the mutation type. So just like when I was fetching data, this time I'm going to start traversing the data graph at the mutation type. The first thing that gets resolved is the mutation resolver, so I'm going to execute my mutation. My data is mutated, and then I'm going to start building my JSON response by traversing that data graph for what objects I want back from my server. And my JSON response that I get back to the server still mirrors that request that I sent in the client's initial request. So I'm going to end with some aha moments from myself learning GraphQL as well as speaking to other developers. This fact that GraphQL is a REST API and more makes a lot of sense. That there's additional things that are required between the contact with the client and the server. There's one endpoint, there's a data graph, and a type system. Another very clarifying concept was that the data server was organized in a data graph. So nodes represent objects and relationships. Between these objects are described by edges. There's no mapping between functions implemented on the server and HTTP methods. This is kind of a hurdle for a lot of developers new to GraphQL to get over, because it's so ingrained that if we want to get or fetch data on our server, we're using a GET request, and if we're modifying something, we're using a POST request. So to use a POST request and not modify data on the server can be confusing. And the fact that our functions are resolvers, and they're defined on each object instead of CRUD operations defined on a resource. So I'll end with this cartoon. I think it's important when teaching people about GraphQL, or if beginners on your team, to really clarify some of these key concepts, because it will make their learning experience that much easier. When you tell them to read docs or try different tutorials, they'll be able to take this information they're learning and store it somewhere useful so that they can remember and retrieve it a lot better, and making their learning more effective. If you found these mental maps helpful today, I posted a Medium post with all the diagrams included and tweeted about it this morning, so feel free to use them. These mental models should be adapted, evolve as you learn new things, make them apply to your workspaces, and yeah, feel free to use them, and thank you so much.